Thank you for joining this lesson. You can subscribe and also share with friends. All right, we're going to handle surface area and volumes of solids. We are told in this question that a solid consists of a cone and a hemisphere. The common diameter of the cone and the hemisphere is 16 centimeters, and the height of the cone is 6 centimeters. Using pi as 3.142, calculate, correct to 2 decimal places. This is very crucial instruction. Correct 2 decimal places. Part A, the surface area of the solid. Let me just sketch the solid. We are having a cone. A cone is usually like this. It's just a pyramid, which is a circular based. Then now, an hemisphere is resting here. Hemisphere is a half of a sphere. So we have the hemispherical part and we have a conical part. The solid now is made in such a way. Now we've been told that the common diameter here is 16 centimeters. That means the radius from this point to the end here, the radius there is 8 centimeters. 8 centimeters. Then again, we are provided with the vertical height. The vertical height, which is equal to 6 centimeters. Now we are demanded to calculate the surface area. We have two surfaces here. One is the curved surface of a cone, and the curved surface of a cone, curved surface for the cone, we use a formula pi r L. In this case, L is the slanting length. So the slanting length can first of all be obtained using a Pythagoras theorem, because the height and the radius are meeting at the center at right angles. Then we can say 6 squared plus 8 squared. Then we obtain the square root, which is going to give us, I think, 10, because 36 and 64 gives 100. Square root is 10 centimeters. So 10 is going to be here. That is the slanting length. Therefore, we can substitute and say pi 3.142 r, which is 8, and the slanting length, which is 10. Therefore, we're going to have 3.142 multiplied by 80. This gives us 251.36. 251.36 square centimeters. The next is an hemisphere. So for the hemisphere, this is a half of a sphere. The curved surface is usually given by 2 pi r squared. Therefore, 2 times pi times r squared. This is going to give us, when we take 2, we multiply it by 3.142 multiplied by r squared. This gives us 402. 402.18 square centimeters. So now after this, we can talk of total surface area. We're going to get when we take and we add 102.18, we're going to get 2. Now let me confirm something. 2 by 3.142 multiplied by 64. This is 402, sorry, not 102. 402, yes. Then we are adding 251.36. This is going to be 653.54 square centimeters. So that is the total surface area. We have a question on volume. The volume of the solid. We are also going to do the two volumes. For the cone, volume will be given by a third pi r squared h. This is going to be a third pi r squared times h, which is 6. So for the conical part, we need a third times 3.142 multiplied by 64 multiplied by 6. This is going to give us a 402.18. 402.18, yeah. This is now cubic centimeters. Then for the hemisphere, volume will be provided by 2 out of 3 pi r cubed. So 2/3 times pi times a radius of 8 power 3. So this is going to be 2 multiplied by 3.142 multiplied by 64 by 8. Then we divide by 3. This is going to give us 1072.47 cubic centimeters. Therefore now, for us to get a total volume, we will need 402.18 plus 1072.47. This is equals to 1474.65 cubic centimeters. Then we are told in the next question, which is the last part, if the density of the material used to make the solid is 1.5 grams per cubic centimeter, calculate its mass in kilograms. It's good to know that mass is usually given by density times volume. Therefore, in this case, we are having a density of 1.5 and the volume as calculated up there is 1474.65. Therefore, when I multiply these two, I will get the mass, but in grams. So 2211.97, sorry, and these are grams. Therefore, according to the instructions, we are to give the mass in kilograms, so we divide by 1,000 to get 2.21 kilograms. So that is the mass in kilograms. Thank you for following. Subscribe and share.